Have you ever stared at a progress bar, watching it crawl at a snail's pace and just wondered, why is this file transfer so slow? You've got a brand new computer, a super fast internet plan, yet sending a simple video to a friend feels like it's traveling by horse and carriage. It's one of the most common frustrations in our digital lives. We think of the internet as this magical cloud where things just appear instantly. But the reality is a lot more complex and frankly a lot more interesting. Today, we're going to pull back the curtain on this digital mystery. We'll dive deep into the hidden world of network transmission to understand what is really happening when you click send. By the end of this, you'll see your internet connection in a whole new light. So, what's the secret? It all comes down to a few key ideas: transport, network transmission, traffic, and bandwidth. These might sound like technical jargon, but I promise they're simpler than you think. In fact, let's use an analogy we can all understand: a city's logistics and road network. Imagine your computer needs to send a large file to another computer across the country. Think of this file as a huge shipment of goods that needs to be delivered from one warehouse to another. You can't just teleport the entire thing at once. First, you have to break it down into smaller, manageable packages. In the digital world, these are called data packets. Each packet is like a small box containing a piece of your file, along with a label that has the destination address and information on how to reassemble it with the other boxes. Now, let's talk about the journey itself. The internet is like a massive, sprawling network of roads connecting cities and towns all over the world. This is our network transmission path. And your internet plan, the bandwidth you pay for? That's like the number of lanes on the highway leaving your local warehouse. If you have a 10-lane highway, you can send out a lot of trucks at once. That's high bandwidth. If you only have a single-lane country road, your trucks have to line up and leave one by one. That's low bandwidth. So, naturally, more bandwidth means you can push more data out the door simultaneously, which should mean faster transfers, right? Well, mostly. But it's only one part of the story. The road network isn't just one big straight highway. It's a complex web of streets, intersections, and traffic lights. The time it takes for one of your little data trucks to travel from your computer to its destination is called latency. Think of it as the travel time. A server on the other side of the world is like a warehouse in a distant country. The physical distance the signal has to travel through fiber optic cables under the ocean and across continents adds to the latency. Every router and switch the data passes through is like an intersection or a roundabout. It has to stop, check the address label, and figure out the best next turn to take. Each of these stops adds a tiny delay, a few milliseconds here and there. But when your data travels through dozens of these intersections, those milliseconds add up, increasing the overall latency. It's like a delivery route with 100 traffic lights versus one with only 5. Now, let's make things even more realistic. Our road network isn't perfect. Sometimes things go wrong. What if one of your delivery trucks hits a massive pothole and a box falls off? That's packet loss. In the digital world, data packets can get corrupted or simply lost along the way due to faulty hardware, signal interference, or a number of other issues. When the receiving computer gets all the other boxes, it will notice one is missing. It then has to send a message all the way back to your computer saying, "Hey, I'm missing box number 734. Can you send it again?" Your computer then has to find that specific piece of the file, package it up again, and send a new truck on its way. This back and forth communication takes time and significantly slows down the entire delivery process. A high packet loss rate is like having a clumsy delivery driver who keeps dropping things and has to go back for them. And of course, we can't forget about traffic. Your data packets aren't the only ones on the road. Millions of other people are also sending files, streaming movies, and playing games. All of their data packets are also trucks on the same highways. When too many trucks try to use the same part of the network at the same time, you get congestion. It's the digital equivalent of rush hour traffic. The highways get clogged and everything slows to a crawl. The routers and switches, our network intersections, get overwhelmed. They might have to ask your trucks to wait in a queue, or if they're completely full, they might just drop your packets, forcing them to be resent later. This is often why your internet feels slower in the evenings when everyone in your neighborhood is online. It's not that your bandwidth has changed, it's that the public roads are jammed. So let's put it all together. The core insight here is that the network, the internet, is an unreliable transport channel. It was never designed for perfect, guaranteed delivery. It was designed for resilience. If one road is blocked, the system is smart enough to find an alternative route. But this resilience comes at the cost of predictable speed. Your file transfer speed isn't just about your personal bandwidth, the number of lanes leaving your house. It's a combination of the total distance the data has to travel, latency, the processing power of every router along the path, the overall congestion on the network, traffic, and the reliability of the connection, packet loss. You could have a 12-lane superhighway leading out of your driveway, but if it merges into a single-lane dirt road a mile away that is full of potholes and bumper-to-bumper traffic, your delivery is still going to be incredibly slow. This is why transferring a file to a server in your own city is almost always faster than sending it to a server on another continent. The distance is shorter, meaning lower latency, and there are fewer intersections, or hops, for the data to pass through, meaning fewer chances for congestion or packet loss. It's also why different file transfer protocols exist. Some are designed for speed, throwing packets out as fast as possible, while others are designed for reliability, constantly checking to make sure every single packet arrives safely, even if it takes longer. They are different types of logistics companies, each with its own strategy for dealing with our imperfect road network. This understanding changes how we view file transfers. It's not a simple download. It's a complex logistical operation, a dynamic dance of data packets navigating a vast and ever-changing digital landscape. Every progress bar represents a journey, filled with potential detours, traffic jams, and lost packages. So the next time you're watching that bar inch along, you'll know what's happening behind the scenes. It's a testament to the incredible complex system that makes our connected world possible, warts and all. But this brings up a very important question. If the network is so unreliable and packets get lost, what happens if your connection completely drops in the middle of a huge, multi-gigabyte transfer? Does all that progress just vanish? Do you have to start all over again from zero? What if I told you there is a way to just pick up right where you left off? This is called resumable transfer, and how it works is another fascinating piece of the puzzle. We'll explore that in our next video. Thanks for watching. If you found this helpful and want to learn more about the tech that powers our world, don't forget to like this video and subscribe to the channel. Let me know in the comments if you've ever had a nightmare file transfer story. See you next time.